Hi guys, welcome to this UKMT Senior Maths Challenge video, and today we are looking at questions 11 to 20 from the 2018 exam. Question 11. How many of the following four equations has a graph that does not pass through the origin? We've got answers as A is 0, B is 1, C is 2, D is 3, and E is 4. So in order for these equations to be passing through the origin, we know that the coordinates that they have to pass through are x is 0 and y is 0. So if we substitute our x value as 0 into all four of these equations, and if we end up getting a y value as 0, then we know that it's passed through the origin. However, if our y value doesn't equal 0, then that must be the equation that doesn't pass through the origin. So let's test it. First equation is y equals x to the 4 plus 1. And we know if we substitute x equals 0 into this equation, we're going to get y equals 1. So this equation doesn't actually pass through the origin. Instead, it passes through the point 0, 1. So we draw this graph. You should know that it's going to look something like y equals x squared, just with a flatter bottom. And of course, if we think about our graph transformations, the graph would have moved up 1 unit parallel to the y-axis. You can obviously see from this sketch that the curve will not pass through the origin. But let's test the other equations just to make sure that they do pass through the origin. So, next curve is y equals x4 plus x. When we substitute x equals 0, we get 0 to the power 4 plus 0, which equals 0. We know y equals x to the power 4 plus x passes through the origin. And then the other two equations are x to the 4 plus x squared and x to the 4 plus x cubed. Basically the exact same equation as y equals x4 plus x. We've just got another multiple of x at the end of the equation. We know that if we substitute x as 0, we are going to get y values as 0. So we can safely assume that both of these curves pass through the origin. Well, and from these results, we've worked out that one equation does not pass through the origin, which corresponds with answer B. So therefore, our final answer is B. Question 12. A regular tetrahedron is a polyhedron with four faces, each of which is an equilateral triangle as shown. A solid regular tetrahedron is cut into two pieces by a single plane cut. Which of the following cannot be the shape of the section formed by the cut? Got answers as A is a pentagon, B is a square, C is a rectangle that is not a square, D is a trapezium, and E is a triangle that is not equilateral. So what I've done is I've enlarged the diagram of this polyhedron, and I'm going to go through each of these answers and see whether we can form each of these shapes from a single plane cut. So answer A is a pentagon. Now we know a pentagon has 5 edges, 5 vertices, and this polyhedron has 4 faces. Okay, so if we start off with an easier example, we've got a plane and we're cutting through the tetrahedron, and let's say we start at this point. So this is basically the first point at which it cuts through the tetrahedron. And what you'll be able to see is that it's going through this face here and this face here. And if the angle's right on the cut, you will be able to form a square. Because what's going to happen is this shape can be formed by passing through each of the 4 faces of the tetrahedron. At first it's going to be cutting this face and this face, and as it gets towards the end it's going to touch the bottom faces. So if we can do the same for the square, we should be able to do the same for a rectangle. And we can, let's say we started up here, across like that. That would work because it would pass through these first faces, and then as it approaches the end, it will touch the bottom faces. So we can do the same for a square, we can do the same for a rectangle. Surely we can do the same for a trapezium as well, because a trapezium is a quadrilateral. One side of our trapezium is going to look something like that, and then you could have another side of the trapezium looking something like that, and then these 2 points could interconnect. So that just leaves us with a pentagon and a triangle that's not equilateral. If you think about an equilateral triangle for a second, you know that could be formed by a single cut. So surely you can do the same for a triangle that isn't equilateral. So we draw our side length. Let's say it looks something like that. And then in order for a triangle to be created by a single cut, one of the vertices would have to pass through this bottom corner here. So therefore that would leave us with the pentagon that couldn't be formed by a single cut. And that is mainly due to the fact that the vertices and the edges of the shape are more than the number of faces of the polyhedron. So therefore final answer is A. Question 13. The lines y equals x and y equals mx minus 4 intersect at point P. What is the sum of the positive integers of m for which the coordinates of P are also positive integers? Got answers as A is 3, B is 5, C is 7, D is 8, and E is 10. Okay, so we know that both of the equations of these lines are going to intersect when the two equations are equal to each other. So because they're both in the form y equals, we can say that x is equal to mx minus 4. If we bring the 4 over to the left-hand side and bring the x over to the right-hand side, we're going to get 4 equals mx minus x. And then what we can do on the right-hand side is we can factorise out x. So we get 4 is equal to x, all multiplied by m minus 1. I think something that's quite important to think about this question is if we draw a graph, what these equations look like. We know that y equals x is obviously a straight diagonal passing through the origin. However, y equals mx minus 1, well, we know the gradient can be anything so long as the intersection is always positive. We obviously know that our gradient can't be 0, because if it was 0, then we would have the line y equals minus 4, which would look something like this, and our intersection of P would be negative. Another good point to realise is our gradient cannot be 1 either, because if the gradient of m was 1, then both of the lines y equals x and y equals x minus 4 would be parallel to each other, so therefore they would never intersect. However, if m is greater than or equal to 2, we know that both of these lines are always going to intersect. But now we have this equation 4 equals x all multiplied by m minus 1. We've got a restriction, if you like, on our values of m. What this equation is basically saying is that x and m minus 1 are two factors of 4. But let's think about all of our factors of 4. Well, we could have 4 times 1, or 2 times 2. So now from these results we could draw up a table of all of our different values for x and m minus 1, and then from there we can find out our values for m. So we'll call this x, m minus 1, and this is m. So if x is 4, m minus 1 is going to be 1. If x is 2, m minus 1 is also going to be 2. And then x could also be 1, and m minus 1 could be 4. So then our values for m is just going to be 1 greater than all of our values for m minus 1. So that's going to be 2, that's going to be 3, and that's going to be 5. And then the question said, what is the sum of the positive integer values of m for which the coordinates? And the question said, what is the sum of the positive integer values of m? And we can get that information by adding all of these values of m here. So if we like, sum of our m values is going to be equal to 2 plus 3 plus 5, which is equal to 10. And 10 is answer E. So therefore, answer equals E. Question 14. The following 12 integers are written in ascending order. 1, followed by 3 x's, followed by 5 y's, followed by 8, 9, and 11. The mean of these 12 integers is 7. What is the median? Got answers as A is 6, B is 7, C is 7.5, D is 8, and E is 9. So we know we can calculate the mean by adding up all the integers, dividing by 12. So we add those, we're going to get 1 plus 3x plus 5y plus 8 plus 9 plus 11. And that's all going to be over 12, and that's going to be equal to 7. So if we simplify the numerator, we're going to get 3x plus 5y plus 29 all over 12 equals 7. So if we multiply both sides by 12, we're going to get 3x plus 5y plus 29 equals 84. That's going to simplify to 3x plus 5y, and then subtract 29 from both sides. It's going to equal 55. Now, to find the median, we need to take the sum of all the integers and divide it by 2 to work out whereabouts the median is. So we've got 12 integers, add 1, divided by 2, it's going to give us 6.5. That means the median is going to be between the 6th and 7th value, which is here where I've drawn an arrow. So therefore, we can say our median is equal to y. So y is the value we need to find. So we rearrange this so we get 3x equals 55 minus 5y. And then we could take a factor of 5 out on the left hand side, so we get 3x equals 5 all multiplied by 11 minus y. So what we can say here now is that 3x is a multiple of 5. And because if we look at our values, x is between 1 and 8. So if x is between 1 and 8, and 3x is a multiple of 5, then surely x must be equal to 5. And now if x is equal to 5, we can substitute that value into our equation to work out y. So we're going to get 15 plus 5y equals 55, which simplifies to 5y equals 40. So therefore y must be equal to 8. And therefore our answer equals D. Question 15. A square is inscribed in a circle of radius 1. An isosceles triangle is inscribed in the square as shown. What is the ratio of the area of the triangle to the area of the shaded region? Got answers as A is pi to root 2, B is pi to 1, C is 1 to 4, D is 1 to pi minus 2, and E is 2 to pi. So, in order to work out the ratio, we need to work out the area of the triangle and the area of the shaded region. So if I draw that as a centre, I can show that as a radius of 1. And I can also show this as a radius of 1. Therefore, from here, because it's a circle, and I know that I can split this centre into 4 different sections, I know that this is going to be 90 degrees. So using Pythagoras' theorem, I can work out that the hypotenuse of this length is going to be root 2. And therefore the area of the square, so if the area of the square is 2, we know that the area of the circle, we know the formula is pi r squared, and we've got r as 1. So the area for the circle is just going to be pi. So the shaded region is going to be pi minus 2. And because this height is root 2, which is root 2 times root 2 times a half, because it's half base times height, which is 1. And therefore the ratio is going to be 1 to pi minus 2, which is answer D. Therefore answer equals D. Question 16. The numbers P, Q, R and S satisfy the following equations. P plus 2Q plus 3R plus 4S equals K, and 4P equals 3Q equals 2R, which equals S. What is the smallest value of K for which P, Q, R and S are all positive integers? We've got answers as A is 20, B is 24, C is 25, D is 77, and E is 154. So we know that S is equal to 2R, which is equal to 3Q, which is equal to 4P. If we write P, Q, and R in terms of S, let's see what we get. So 4P is S, so P will be a quarter of S. 3Q is S, so Q will be a third of S. 2R is S, so R will be half of S. And then of course S will just be S. We're told that P, which is a quarter of S, plus 2Q, which is 2 times a third of S, plus 3R, which is 3 times half of S, plus 4S is equal to K. If we simplify this, get a quarter S plus 2/3 of S plus 3 over 2S plus 4S equals K. With 4, 3 and 12, I can see a common denominator of 12. So we make that 3 over 12S plus 8 over 12S plus 18 over 12S plus 4S. And that simplifies to 29 over 12S plus 4S equals K. And then if we multiply through by 12, we're going to get 29s plus 48s equals 12k. And 29s plus 48s is 77s, which is equal to 12k. And the question is asking us, what is the smallest value of k for which p, q, r and s are all positive integers? Now if we say s is equal to 12k over 77, but then in order for 12k over 77 to be a positive integer, k would have to be 77. Because if k was 77, then those 77s would cancel out and you would be left with 12. Anything smaller than 77 would not simplify to an integer. So therefore, answer equals D. Question 17. Bethany has £11 coins and some 20p coins and some 50p coins in her purse. The mean value of the coins is 52 pence, which could not be the number of coins in the purse. We've got answers as A is 35, B is 40, C is 50, D is 65 and E is 95. So what we can do, let's say the unknown value for the total amount of 20p coins is represented by X. So X is going to be number of 20p coins. And then we can say that Y is the number of 50p coins. So we can form an equation by working out what the mean is using the values of X and Y. First we need to make sure whether we're happy with working in pounds or pence. I think I'm going to work in pence. I think it's going to be a bit more easier. Rather than £11, we can have 1,100p plus 20 multiplied by some X plus 50 multiplied by some Y. And then of course when you do the mean, you do it all divided by the total number of coins. So there's going to be £11 coins, there's going to be X 20p coins, and there's going to be Y 50p coins. So we divide by 11 plus X plus Y. And that is all going to equal 52. So now we've got an equation. Let's try and simplify this and get it in the form of just X plus Y. So what we can do is we can multiply both the left-hand side and the right-hand side by 11 plus X plus Y. So we're going to get 1100 plus 20X plus 50Y is equal to 52 times 11. Now, we know 52 times 10 is 520. So we do 520 plus 52. That's going to give us 572. And then plus 52X plus 52Y. Okay, so first I'm going to minus 572 from both sides. 1100 minus 572 is 528. And then we can make this equal to, if I subtract 20x from both sides, I'm going to get equal to 32x. Subtract 50y from both sides and I'm going to get plus 2y. Now what I'm going to do is, because my y value has the smallest multiple, I think I'm going to create an equation that says y equals some function of x. So if I say 2y equals 528 minus 32x, now I can divide both sides by 2, so I get y equals, divide 528 by 2, you get 264. Divide 32 by 2 and you get minus 16x. Now, so we've got a formula for the number of 50p coins. But of course, we can only really form one equation just from calculating the mean. It's not too obvious what other equations we can create from this to then maybe solve simultaneously. But what I'm thinking is we could take the total of all of the coins, make that a separate formula, and then we can see whether we can eliminate some of the x and y terms. But remember, the question doesn't say to find what x and y are. It says to find what x plus y could not be. So what I'm going to do is I'm going to create a formula for the total number of coins, and I'm going to call it C for coins, which is going to be equal to 11 plus x plus y. And then what I can do is, because I've got this formula for y equals 264 minus 16x, I can substitute that into this formula for c. So I'm going to get c equals 11 plus x plus 264 minus 16x. Now that's going to simplify to c equals 275 minus 15x. If I rearrange this equation to get 15x equals 275 minus c, then I can use my answers that I've been given in the question to substitute for c. And what this is basically saying is 275 minus c is equal to some multiple of 15. But of course, it's only a multiple of 15 if c allows us to simplify the equation to something that we can then divide by 15 to get an integer value for x. So let's have a look. Let's start with a. A is 35. So let's use the first answer. A is 35. So we can say 15x is going to be equal to 275 minus 35. Well, that simplifies to 15x equals 240. So let's check whether 240 divides into 15. So how many 15s go into 24? We say 1 for a remainder of 9. How many 15s go into 90? That would be 6. So x equals 16. Well, what that means is 240 is a multiple of 15, which we don't want because we're trying to find an answer which wouldn't be the total number of coins. So if we have an integer value for x, then substitute that x value into our equation for y equals 264 minus 16x, then we're going to get an integer value for y, which we don't want. A can't be our answer, and I'm going to try our next answer, which is 40. So we get 15x is equal to 275 minus 40, which is 15x equals 235. So again, let's see if 235 divides into 15. How many 15s go into 23? We've got 1 with a remainder of 8. How many 15s go into 85? Now, I know that that is 5 with a remainder of 10. 5 with a remainder of 10. And of course, because we've got this remainder left over, that would mean that 235 is not a multiple of 15. So B could be likely. That could be our answer. But I do want to check the other answers first, just to make sure. So let's try C as 50. We get 15x equals 275 minus 50, which is 15x equals 225. Well, I know 15 squared is 225, so I know 225 is going to be a multiple of 15. So that wouldn't give us our answer. So let's try D. D is 65, so we try 15x equals 275 minus 65. That gives us 15x equals 210. Well, I know that 210 divided by 30 will give me 7. So if I divide it by 15, probably that will give me an answer of 14, which is an integer. So that can't be our answer. Let's try the last one, E, 95. So that's going to be 15x equals 275 minus 95. 15x equals 180. So again, I know 180 divided by 30 is 6. So therefore 180 divided by 15 should be 12, which is an integer. So therefore, I think it's safe to say that our answer is B. Question 18. P, Q and R are the three angles of a triangle. When each has been rounded to the nearest degree, which of the following is the complete list of possible values of P plus Q plus R? Got answers as A is 179, 180 or 181, B is 180, 181 or 182, C is 178, 179 or 180, D is 180, E is 178, 179, 180, 181 or 182. So the first thing to think about is obviously the sum of the angles within a triangle will add up to 180 degrees. So we can say P plus Q plus R equals 180. And another thing we know is that when an angle is rounded up to the nearest degrees, it will be increased at most by 0.5 degrees. And also, when an angle is rounded down, it will have decreased by at most by 0.5 degrees. And we can say that for all three angles P, Q and R. But P, Q and R are the exact angles. We want to work out what the rounded angles are. So if I call this P dash, Q dash, R dash, we can say that P is going to be between P dash less 0.5 and P dash is greater than 0.5. We can also say the same for Q dash. and also the same for r dash. And therefore, using all these three equalities, we can generate an equality for p plus q plus r. So we say p plus q plus r must be between p dash plus q dash plus r dash is less than minus 1.5, and then p dash plus q dash plus r dash plus 1.5. And because the total values of p dash, q dash and r dash is 180, the inequality would be between 180 minus 1.5 for p plus q plus r and 180 plus 1.5. So that simplifies to 178.5. And this simplifies to 181.5. So now we need to see which answers satisfy this inequality. So A is 179, 180 or 181, which does satisfy this. B is 180, 181 or 182. Well, 182 is outside of the inequality, so it can't be B. C is 178, that's outside of the inequality, so it can't be C. D is within the inequality, but we know it's got more values than 180, so that can't be the right answer. And then E is 178, 179, 180, 181, 182, 182 and 178 are outside of the inequality, so it can't be E. So therefore, our final answer must be A. Therefore, answer equals A. Question 19. How many pairs of numbers mn are there such that the following statement is true? A regular m-sided polygon has an exterior angle of size n, and a regular n-sided polygon has an exterior angle of size m. We've got answers as A is 24, B is 22, C is 20, D is 18, and E is 16. So, in order to calculate the exterior angles of any polygon, we need to do 360 degrees divided by the number of sides. So in this case, for the first part of the statement, this bit, divided by m, which equals n. Of course, that's going to be 360, which equals nm. And the second part of the statement is going to be 360 degrees divided by n, which equals m. And of course, that becomes 360 equals mn. Both of the statements give us the exact same result. And what you'll see is it's basically an equation where m and n are all of the factors of 360 degrees. But we've got to be a little bit careful here, because rather than finding all of the factors of 360 degrees, we've got to think about the context of this question. We have to think about the number of sides of a polygon, and that is every polygon has at least 3 sides. Because obviously if it had one side, it would just be a straight line. And if it had 2 sides, it would just be an angle. So we need to have at least 3 sides. So therefore we can say that n needs to be at least 3 and m needs to be at least 3. So now what we can do is we can go through all the factors of 360 degrees, but m and n have to be at least 3. So the first one is going to be 3 multiplied by 120. We're going to have 4 multiplied by 90. 5 multiplied by 72. 6 multiplied by 36. 7 is not divisible by 360. 8, well, we know 4 is 90, 8 is going to be 45. 9 is 40. 10 is 36. 12 is 30. 13 is not divisible, 14 is not divisible. 15 would be 24. 16 is not divisible, 17 is not divisible. 18 would be 20. And then of course the next number, 19 wouldn't be divisible, 20 would, and of course the other factor of 20 would be 18. So these are all our possible factors for mn. There's 10 different results there, but of course we have 2 equations, one where m is the number of sides and another where n is the number of sides. So the number of pairs of m and n is going to be 10 times 2, which is 20. We've got an answer for 20, which is C. Therefore, answer equals C. Question 20. The diagram shows a semicircle of radius 1 inside an isosceles triangle. The diameter of the semicircle lies along the base of the triangle, and the angle of the triangle opposite the base is equal to 2 theta. Each of the two sides of the triangle is a tangent to the semicircle. What is the area of the triangle? We've got answers as A is a half tan 2 theta, B is sine theta cos theta, C is sine theta plus cos theta, D is a half cos 2 theta, and E is 1 over sine theta cos theta. So the question says that the two equal sides of the isosceles triangle are a tangent to the semicircle. So if we draw 2 points going from the centre of the circle to the sides of the isosceles triangle, where the circumference is touching the sides of that isosceles triangle, we can say that these angles are going to be perpendicular. And then these lengths are going to be equal to 1 because it's the radius of the semicircle. And then if we divide this in half, we've basically got two separate right angle triangles. One here, which is going to be theta, and another one here that's going to be theta. If you like, both of these right angle triangles are congruent. So if I draw one of these triangles, we know that this is the hypotenuse, this is the opposite side, and this is the adjacent. So to get the area of the triangle, we need to do a half of the base times by the height. Well, the height is going to be the hypotenuse in this case. So we say that sine theta equals opposite over hypotenuse, which is 1 over the hypotenuse. Then we can rearrange this to say that the length of the hypotenuse is equal to 1 over sine theta. But the other thing with this question, the base is not 1, because that is the radius of the circle, not the whole base of the triangle, because there's these little bits left over here. So what you should be able to notice is obviously this angle is going to be 90 degrees. We can say that this is going to be a similar triangle where this angle will be theta. So we want to find this length here. That side is going to be the adjacent. That side's going to be your opposite side, and that's going to be the hypotenuse. So in order to find the hypotenuse, we need to do cos theta equals adjacent over hypotenuse. So cos theta equals the adjacent, which is 1, all over the hypotenuse. And if we rearrange this to find the hypotenuse, we get 1 over cos theta. So therefore, we've now got all the components in order to work out the area of this triangle. The area is going to be a half base times the height. Well, the base is going to be twice of 1 over cos theta. So it's going to be half multiplied by 2 over cos theta times the height, which is 1 over sine theta. Those 2's are going to cancel out, and you are just going to be left with 1 over sine theta cos theta, which is answer E. Therefore, answer equals E. Thanks for watching. Don't forget to subscribe. You can check out my other videos on this page. And also, if you've got any questions or any video suggestions, just leave a comment down below.